This video is about example number 4 regarding vectors. Let's say we have a box of supplies that weighs 1,200 pounds and is suspended by 2 cables attached to the ceiling. The question is, what are the tensions in the 2 cables? So let's make sure we understand that what we have is a box that is creating a force straight down due to weight. So we'll call that FW for force due to weight. At the same time, since the box is not going down nor going up, then these 2 cables must be supplying some more force, or tension is what we call it, such that the box will stay in equilibrium or suspended. So our job is to find each of these forces. So we'll just call them F1 and F2. What we can do now is actually write each of these 3 forces in terms of horizontal and vertical components. So let's start off with the force due to weight. For the force due to weight, we can see that there is no left and right component, so that's going to be 0. And the vertical component is going straight down, so that's going to be a negative 1,200. So that is the force due to weight. So now we need to go find F1 and F2. For F1, we're going to write down our 2 forces. I'm going to write it down twice and you'll see what I'm talking about. So one of the things is we need to find what the actual force is, which is our tension. So we're going to call it T for tension. And then the horizontal part we're going to see is a cosine of that 30 degrees. So this will be cosine of 30 degrees. And over here will be that tension, whatever that tension is, and sine of 30 degrees. So we can actually find this to be, knowing that the cosine of 30 degrees is the square root of 3 over 2, and sine of 30 degrees is 1/2. So we can write it like this. The last thing we need to do is go find F2, the force due to that one. And again, we need to know what the magnitude is, which we don't know. So what we're going to do is we're going to call that T2. So I'm going to come back up here to my F1s and call those T1s. And I'm going to say that I need to know the tension in the second one. And again, I'm going to do cosine for the horizontal. In this case, it's going to be 45 degrees. I do the same thing for the vertical, so T2 sine of 45 degrees. And we actually know those values, so we're going to find that that's going to be the square root of 2 over 2 T2 and square root of 2 over 2 T2. Now again, I'd used T1 and T2 for the tensions, but we could have used different letters. And in fact, I might just change those in just a second. So for something to be in equilibrium, it means that if you add all the forces, if you add up all the forces, you're actually going to end up with a 0 vector, meaning that nobody is moving, not left or right and not up and down. So if you think about it, we're going to sit here and say, all right, if I add up all the x's, so I'm going to do horizontal components, from F1, W, I'm going to get 0. From F1, I'm going to get the square root of 3 over 2 T1. And for F2, I'm going to get the square root of 2 over 2 T2. And that has to equal to 0. We do the same thing with our y components or our vertical components. I'm going to get negative 1,200. That's from my FW vector. Then from my F1, that's going to be 1/2 T1. And then from my F2, it's going to be the square root of 2 over 2 T2. And that has to equal to 0. So check this out. What we find from the very first x components, we find that the square root of 3 over 2 T1 plus the square root of 2 over 2 T2 is equal to 0. And then I'm going to do the same thing here for the y values, except I'm going to bring this over here to the other side. So that gives me 1/2 t1 plus the square root of 2 over 2 t2 is equal to 1,200. And this, ladies and gentlemen, is a two-equation system that we should be able to solve. So I'm going to change these into x's and y's so that it looks familiar to you. So square root of 3 over 2x plus the square root of 2 over 2y is equal to 0. I'm going to do the same thing over here. I'm going to have 1/2 x plus the square root of 2 over 2y is equal to 1,200. I'm going to multiply all my equations by 2, everybody by 2. So I have to solve the square root of 3x plus the square root of 2y is equal to 0, as well as x plus the square root of 2y is equal to 2,400. Remember what I did is I multiplied everybody by 2 to get rid of fractions. For our systems of equations that we need to solve, I'm going to multiply one of them by a negative. So I'll multiply this one by a negative. So that's going to give me negative square root of 3x minus square root of 2y is equal to 0. My other equation is x plus square root of 2y is equal to 2,400. I'm going to add down so that my y's will cancel out, and I end up with 1 minus the square root of 3x is equal to 2,400. And now I can actually solve and get a number for x, which is 2,400 divided by 1 minus the square root of 3. So this will give me some number. Remember, that is the same thing as tension 1. So that will give me how much tension is on that first cable. Likewise, once you find that number, plug it into one of these original equations and you should be able to find T2. And that concludes this video.